Hello YouTubes, welcome to another exciting episode of ElecTrainics. Today we're going to be hopefully converting this vintage Bachmann passenger coach to LED flicker-free lighting. It does already have electrical pickups, but let me show you what it looks like on the track and then you'll know why we're going to upgrade it today. Need I say more? On the last video, we went over the basics of LED lighting and we realized that LED lighting is polarized, as in it has to be wired positive and negative, and it will only work that way around. So on a DC powered system, if you want your trains to run in reverse, when the positive and negative is reversed, it means your LED lighting isn't going to work. So today, we're going to overcome that little issue and we're going to add a little device to stop it flickering, hopefully. These are the components we are using today. LED strip lighting, 12 volts. We discussed this in the previous video. Every 3 LEDs has its own little resistor, so we can basically cut this to the length we require in sections of 3 at a time. I have gone for the bright white LEDs as denoted by the white dot on the packaging. They do come in a warm white, but since the passenger coach is relatively modern, I want a bright white LED strip for that. Next along, what looks like an alternator belt is actually just a strip of these tiny little bridge rectifiers, if you can even see that. That is going to solve our forward and reverse issue that we spoke about earlier, if I don't drop it and lose it in the floor first. Next along, we have a capacitor, which is going to hold the power for a little while so that it doesn't flicker. And if we're feeling really extravagant, we have a potentiometer to adjust the brightness. Don't worry, I will explain what each thing does as we go along. So let us begin with the LED strip. So we need to decide how much we need. We'll do that by removing the body, if it wants to come off. That sounded like I broke it, but I think we're okay. And we're going to stick this along the inside of the roof. So I think between that point there and that point there. So let's measure out. Bear in mind, we have to keep it in 3s. Well, that's going to be ideal. So if I cut it in that one, and there's a little line across those little copper contacts, cut it right in the middle. And that has got our length we require. That is going to fit in between those two. Don't worry, it'll work. That's going to stick in there, but we do have to remove this sort of fibre optic panel first. Don't worry, I'll do that off camera because it could be quite horrific and quite messy. Okay, so this has got the length that we require. We will work out how we're going to get the wires up from the rails later. First thing we need to do is sort out all this. Let me move everything else out the way. To make life easier, I have secured the little LED strip to the desk. Now, let's give it some power and we'll see what happens. Positive is red, black is negative, and we have lights. But as you know, if we reverse the polarity, let's simulate we're going in reverse in the train, we have nothing. So it is time to rectify that little problem with a rectifier. I need to zoom in, this is tiny. So here we are, we have 4 little legs you might just be able to see that on that side we have a negative and a positive. Those two little legs are going to go to the LED. So that would be the positive of the LED and that would be the negative. These two legs are the input from the track. And it doesn't matter which way round we solder our track power to. The great thing about this bridge rectifier also works on AC for a DCC layout. And it's quite clever how it works. If you imagine inside this little box, there's a little clock, a little wheel that's constantly rotating clockwise. It's not, but just imagine, okay? So you've got signals coming in and they go round and round, they cannot go backwards. So whatever happens to the power going in, it always sends negative out that leg and always sends positive out of that leg. This is especially useful in an AC system where it's alternating current. It will always be going round, kicking out negative, kicking out positive. So that's the basics. It's not technically correct, but it's just how I envisage it, okay? So all we have to do is solder the positive onto the positive side of the LED strip and the negative onto the negative side of the LED strip. Hook these up to the track power and hey presto, it will work. I hope. Let's find out. Let us start by putting on just a tiny bit of flux there and then a little bit of solder on each terminal. Like so. Move our little bridge rectifier into position. Drop it on top, a little bit of solder. And it's on. So with a bit of luck, all we need to do now is connect the power left and right, either way round. This should light up. Fingers crossed. Track power is on. Let us connect positive to this side to begin with. Negative to that side. And we have lights. Working fine. Let's swap them over. So the positive now is on that side. And oh yes. Lights both way. Just in case you thought I was cheating. Perfect. Well, that was easy. What do we do next? Let's see if we can solve the flickering issue by using a capacitor. Let me explain what these are all about. From what I understand, capacitors are kind of like crappy rechargeable batteries. They take in some power and then they expel that power fairly quickly. They don't store it for very long as soon as you cut the power. There's obviously lots of differences, but the main thing you want to look for installing this onto your train, either your locomotive or your coaches, is the voltage. These ones are 16 volts, which should be fine. You don't want to go any lower than 16 volts. And this number up here that says 1000, it's 1000 microfarads. It's a techie term. I don't really know what it means, but what I do know is the bigger that number, the 1000 number, the longer it's going to hold that power. For example, here is another 16 volt, but this time it's a 2200 microfarads. So that's going to hold it for maybe twice as long as that one. And this one, Giganticus, is a 4700 microfarad, but this one is actually rated to 25 volts. Doesn't mean you can't use it. It's just a wee bit more than you need. But basically, anytime that number gets bigger, that number usually gets bigger as well. So what we'll do is, we will start with the smallest one and see how long it keeps the lights on. Other thing to note, these are also positive and negative. You can see there, that's a bit of a giveaway, that leg is the negative. It's also shorter, kind of like the LEDs themselves. Longer one needs to go to positive, shorter one needs to go to negative. And all we're going to do is solder this on to the positive and negative of the LED strip. So we're now at the opposite end of the LED strip. Positive is this side, negative is this side. As before, using my fancy flux pen, get a bit of flux on there, but I'm also going to add some solder onto the ends of the capacitor. Kind of tin them up. Let's do that first actually. It's a bit dirty, should have cleaned my soldering iron first. Rookie mistake. It's a bit better. I'll get a bit of solder onto the contacts at the end of the strip. Doesn't take much. Now we can solder this on. Make sure negative is this side on the negative side, positive on that side. Connected. Okay, now to test. Track power is on. Let's just make sure it still works. Yep, I'm going to disconnect the negative. Well, that doesn't last very long, does it? Let's try it with slightly less voltage. So that's obviously not working very well. There's two things we can do about this. We can replace our capacitor for something bigger, or we can add another resistor. I think what I'd like to do first, since we've got the soldering iron out, I am going to remove this capacitor and try the giant one, just to make sure there is a massive difference. Trim that down a wee bit. Turn this up. Actually, I'm going to bend it that way a little bit, make life easier for myself. Get a bit of solder on this. And solder this on to the end of... Wow, it gets dirty fast. I'm not liking that flux that I've been using. Seems to get dirty pretty quickly. Right, let's get this on. That's the wrong one. Let's try that again. Positive side on. Negative side on. Okay, let's try the power again. And hopefully it will stay on for more than, well, it'll stay on at all would be good. So we have power. Oh, that's better. Full power, letting go now. So let's simulate a bad section of track. It is actually still lit, by the way. Power on. So that's kind of rubbish, to be honest. And the reason is, it is sending all the power from the capacitor through the whole system straight away. We can slow that down with a resistor. Let's try adding a 1000 ohm resistor between one of the legs of this giant capacitor and either the positive or the negative. It shouldn't really matter which way around. Let's go with the negative. What we're trying to do here is just slow everything down a bit. So yeah, it might take a wee bit longer for the capacitor to charge up, but it should also, hopefully, in theory, slow it down from releasing. It's a work in progress. So we are going to intercept from that leg to that connection with this capacitor. So bend that round here. It doesn't need to be neat and tidy at the moment. I just want to see if it's going to work. So some of my horrible flux that I no longer like at all. But it's all I've got at the moment. Or at least it's all I've got handy. Clean up my soldering iron tip. Get some solder on that. One side. Oh, for goodness sake, let's cut this down a wee bit. It's just ridiculously long. Okay, we'll get this soldered on here. Get a blob on there. And we'll connect it down there. This is purely test purposes. Okay, so now we have positive going into the capacitor, negative coming out through the resistor. Hopefully slow things down. And just see if it holds the light for just a bit longer. Okay, let's see what happens. I'm going to go full power with my power controller. Connect the power now. Wow, and now it's not working at all. That was very interesting. I mean, it is working, but it's releasing most of its power immediately. It's still lit. You know what? It's still lit. I think we need to reduce the amount of power coming in. So how about we install a potentiometer to reduce that power coming in. It's still lit, by the way, so it's that blinding light that we're trying to get rid of. This did no good whatsoever, so I might just remove that. So this is our potentiometer. It's basically a variable resistor. You can see the slot in the end. You can turn it clockwise, anti-clockwise, and it increases or reduces the amount of power flowing into whatever it is you're hooking it up to. On the back side, you have two outer prongs, one center prong. I'm going to hook up the center prong to one side of the bridge rectifier and either one of these to the other side. I don't have a lot of meat there, so I'm going to try and straighten out these little legs. Just gives a bit more room. These little bridge rectifiers are designed to slot onto circuit boards, that's why they're shaped that way. Okay, that gives us a bit more room. Let's tin them up. Okay. Now we need to shape this. Obviously that's too far apart, so let's just bend these down a bit. And straighten that as well. Again, these are designed to slot onto something. a circuit board. They're probably quite a specific shape and design. Certainly not shaped and designed for this purpose, I tell you that. So bend that in a bit. Bend that one in a bit. Needs to be closer. Goodness, this is tiny. Yeah, that should do there. Let's bend this one out of the way for now. Don't worry, we will be using this later. But we don't need it right at this second. Okay, so you can see the two ends that I'm going to solder on. Let's get a bit of solder in them as well while we're at it. Okay, I'm going to do this left-handed. So it could be a complete disaster, but it really shouldn't need much to join it on. One side. Two. So now we can attach the power, see if this works. Now I do need to make up a couple of crocodile clips to hook on because I want to be able to hold this and turn it to adjust the, I was going to say volume, but you know what I mean, to adjust the, what's that? Oh yeah, that's the third leg. Oh, goodness. To adjust the brightness, that's what I'm trying to say. Right, back in a second when I've got these on wires. I have now removed that resistor from the capacitor, and it was actually working better without the resistor there. And I've got my crocodile clips ready. So one side of the power in is going to the outside leg there. The other wire come from the transformer goes to the other outside leg there, which is connected to one side of the bridge rectifier. The other side of the bridge rectifier is connected to the middle pin. Oh my goodness, this is hard to see. Anyway, let's fire it up, see what happens. So I'm going to set the voltage to maximum, because why not? Give it some power. See what happens. It should at least light up because I know that this potentiometer is set to the middle for now. Anyway, let's find out. Power on. We have no... Oh, we do have light actually. Okay, so it is doing something. Let us adjust the voltage coming in. Oh, okay. So that is the voltage up, nice and bright. So let's set it to about there. Hopefully you can see that. And we're going to try disconnecting the power here. That is much better. I'm wondering if you would notice that, because remember, dead spots only last for a couple of milliseconds. Let's try turning the volume. I keep calling it the volume. Let's turn the voltage down even more, because there is a lot of LEDs in there. It might be much brighter once it's in an enclosed space. Oh, that's obviously too bright. Let's turn it right down to about there. See what happens this time when we disconnect. Not bad, they are staying on. Let me turn this light way down, might give you a better idea. Right, I've actually turned all the lights off. There's some daylight coming in the window, and this has been disconnected now for quite a long time, and it's still lit, but not very bright. So here's what happens when I touch the power. It's bright, and I'm going to randomly lift off now. On, off, on, off, on, off. So we're disconnected, and as you can see, it's still lit, and that will stay lit for like a minute, but not very bright. So what I think I'll do, I'm going to swap out this gigantic capacitor for the next one down, because it seems to be flooding the strip with power briefly, and then it settles down. So I think it's just too much power in that capacitor. We'll give it a shot. Be back when I swap this over, okay? So I swapped out the 1000 microfarad capacitor for the 2200 microfarad capacitor, the bigger one. It helped a bit, but it's still not acceptable. So I think I know what the issue is. Too many LEDs sucking all the power out. So here's what we've done. So we started off with 15 LEDs and I cut 6 of them off. That made it a bit better. Then I cut off another 3. And now it's working not too bad. Let me show you. Put on my noisy controller. Connect power now. Nice and bright. Lift off. Staying bright. On, off, on, off. And that would be your sort of dead spot flicker if I was to tap it like that. And it stays on for quite a while. So either I need to add bigger capacitor, or I could double up in this capacitor, which is what I think I'll do, because these gigantic capacitors cost rather a lot of money. And I think 2 of them would probably be fine. Now, the problem is that means that only this section of the coach is going to be lit. However, what I could do is cut it here, move this section along, and just run a couple of wires to complete the circuits that I've now... Basically, I'm stretching those little brass connectors. So if I cut it there, move it across, add wire there, and hopefully that'll be enough to light our coach adequately. So let me do that, and we'll see what the final circuit looks like before we stick it into the coach. My homemade LED lighting with Keep Alive is now complete. Let me give you a closer look. So we have 2 2200 microfarad capacitors, 16 volt, wired in series. Little extension wire. 3 LEDs. Has its own little resistor. Extension wire. 3 LEDs. Little resistor. We have the bridge rectifier. Little extension wire. Potentiometer to adjust the brightness. And I've fitted a little wire with a micro plug, which will plug into the wire coming from the track through the base of the coach itself. Right, let's switch on, see how it looks. I will, of course, have to dim the lights for full effect. And we have lights. Unplug the lights. Plug the lights back in, out, in, flicker. Very slight flicker. And the only way round that little flicker is to either reduce the amount of LEDs or add even more capacitors. But I don't really want to do that because they're quite expensive, and I think that'll do for now. Won't really know until we're in the coach and going round the track. Lights on, please. So all that's left to do is install all of that into the roof of my passenger coach. I've left it a little bit long because this bit of wire has to go round that screw receiver and I'm going to install the potentiometer in that edge, and I will have access to adjust it without dismantling the whole thing. But let me stick all that in there. Let's see how it looks when it's all done. Passenger coach is ready for reassembly. Everything is glued down, and I used hot glue. I think that looks fairly neat, happy with that. My little potentiometer down there. You're probably wondering how on earth I'm going to reach that when the body is on the chassis. Well, let me show you. I have drilled a little hole right there so my screwdriver can fit through the hole from the underside and reach all the way up to the potentiometer, which is right next to this section here. Been very carefully measured, and by measured I mean guessed, but it should work fine. Okay, time to plug this all together. Put this over there, screw it together, and I'll see you at the track. Here we are then. DC power, let's give it some. See what happens. Hopefully it doesn't blow up. Ooh, that's nice. We are not even at a quarter power. So normal running speed would probably be about there, which is about a third. Does it flicker? No, it doesn't. Very nice. Let's see how bright it goes. That's about half power, half, 3/4. Doesn't get too much brighter, to be honest. Fairly consistent all the way. Still no flickering. Oh, that's awesome. Really happy with that. Let's take it down to half power. And just for a laugh, let's hook it up to his old-fashioned incandescent brother. So that is LED with a keep alive. And this is incandescent without keep alive. Having a disco in there really doesn't do much compared to that. Oh, that's excellent. Now, while we're at it, let's switch over to DC power. Hopefully we won't blow it up. So DC power down. And we're on DCC power or AC power, which is a constant 14 or 15 volts. And that's where the bridge rectifier is coming in, because it's converting the AC power to DC. And that is a nice brightness, I like that. And flashy Mike Flasher over there. Much brighter now because he's getting a constant 14 volts as well, but still orange, still flickery and annoying compared to that. Oh, so chuffed with that. Fantastic. Can't believe that actually worked. Not bad for my first attempt at a DIY keep alive with LEDs. Really happy. So I suppose I better hook it up with its friends and a Via Rail locomotive, take it for a spin round the track. Bit of a disaster, need to tidy up before I do the next project. But you know what, leave a comment. What do you think I should do next in the ElecTrainics thing? There's a lot to cover, but I'm open to suggestions. That was great. I'm just over the moon with the results. Take care everyone, thanks for watching, see you soon.